Today we're going to look at 1-6, solve linear inequalities, and 1-7, solving absolute value equations and inequalities. With inequalities, let's go ahead and review what the signs are. So we have greater than, and then remember when you graph greater than is an open circle, and then the numbers that are getting larger and larger to the right. Greater than or equal to, closed, because that means that the number itself is also in the set, and then pointing towards the larger numbers. Less than, open circle, pointing towards the smaller numbers. Less than or equal to, closed, and pointing towards the smaller numbers. So an example would be if we graph x is greater than 3. So we'd have a number line, 0, 1, 2, 3. Open circle because it's just greater than, and to the right since it's greater than. Alright, so with compound inequalities, we have ands or we have ors. So an and looks like this, where we have 3 is less than x is less than 4. So compound inequalities that are ands can be written like this, together. We think of this in terms of between, because the solution lies between these two numbers, and the graph kind of looks like a barbell. And then the other one is or. Or has to have the word or in it. So there's no other way to write an or statement unless you have the word or. And with an and down here, we could have written this using the word and as well. So either and looks like this, or it has the word and. Or only has the word or. So this graph, we're going to have -5 and -2, so the smallest number goes to the left. And then open circle and open circle. And then ors go out most of the time, and occasionally they overlap. But for most of the time, ors go out. So if you think of it like a boat, and oars are hanging out of the boat. Alright, so the next one we're going to do is we're going to go ahead and solve and graph. One of the things we need to remember is when you multiply or divide by a negative, you have to remember to flip over the inequality. Flip over the inequality. Okay, so let's go ahead and practice one of these. So for example, we'll do 15 minus 3x is greater than 3. So minus 15, just like you're solving equations, -3x is greater than -12. Divide by -3. So we have x, and then because I divided by a negative, I have to flip the inequality, so notice it changed directions, and then the equation just works like it always did before. So we have a number line, put 4, and then open circle, and to the left. Alright, so the next thing we're going to do is solve the compound inequality. So we're going to use one of those ors or ands. So we'll start with an and. So we'll do -3 is less than 4 minus 5x is less than or equal to 6. So we know this is an and because it doesn't have the word or in it. So on this one, we want to get what's in the middle by itself. So it's like solving an equation that has two sides. So whatever we do to the middle, we'll have to do to the left and to the right. So just like in the equation, we're going to try to get x by itself. So I'm going to -4, -4, and -4 one more time. So this is going to make -7 is less than -5x is less than or equal to 2. And then again, I want to get what's in the middle by itself. So I'm going to divide everybody by -5. So I have to write it all 3 times. So this makes +7/5. This makes, oops, made a mistake there. We need to flip over the inequality. So we've changed this. This makes x, and we need to flip over this inequality, and this makes -2/5. Because we divided by a negative, we have to change the direction of the inequality. And then if we graph, negative 2/5 would be here. Positive 7/5 would be here. X is less than 7/5, and X is greater than or equal to negative 2/5, so it makes a little barbell. It looks like a line segment. All right, the other one we're going to do is an OR. So we're going to have 2x minus 3 is less than or equal to negative 4, or 3x plus 1 is greater than 4. So we know this is an OR because it has the word OR in it. So in this case, we have to solve the equation twice. So we do this equation on the left first. Go ahead and finish it all the way out. We don't have to flip the inequality over because this time we divided by a positive 2. And we write the word OR, and then we work out the equation on the right. And then we have x is greater than 1. So we draw our number line, negative 1/2, 1, close circle. This goes to the left because it says less than, open circle. This goes to the right because it says greater than. Alright, the next thing we're going to do is absolute value. So absolute value, if you remember, means the distance from 0. So it's how far something is from 0. So if we look at a number line, 0 is in the middle. And there's two sides from 0. There's a positive side and there's a negative side. So if I'm 5 units from 0, I could be 5 units from 0 at positive 5, or I could be 5 units from 0 at negative 5. So we have two values that work. And so that's why the absolute value of x, if it equals 5, x could be positive 5 or x could be negative 5. Alright, so let's go ahead and solve one of these. So we have x minus 5, absolute value x minus 5 equals 7. So if we look at this inequality, we have this equality, we have this absolute value that's equal to 7. Anytime we have one of these, it always means OR. So we have a problem where we're going to separate this into x minus 5 equals 7, or x minus 5 equals negative 7. So what changed was the 7. So notice that everything else stayed the same, but the 7 and the negative 7. So now I'm going to add 5 to both sides, x equals 12. Or add 5 to both sides, x equals negative 2. So if we graph this, negative 2 and 12, these are just 2 points on a number line. So that's the difference between an inequality and an equality. Here we don't have any arrows because it's exactly 12 and it's exactly negative 2. We do want to check to make sure that it works, so we'll plug the numbers into the equation. So we're going to have 12 minus 5, which is 7, and the absolute value of 7 is 7. So this guy's good. Then we're going to take negative 2 and plug it into the equation. Negative 2 minus 5 is negative 7. The absolute value of negative 7 is 7. So this is also good. Alright, the first thing we're going to do is look at absolute value inequalities. So on these, we're going to have less than or equal to. And when we say these for absolute values, we're going to say less and we're going to say than. Kind of a funny way to say it, but that's a good way to remember that less than means and. And then for greater or greater than or equal to, we're going to say great or. Again, trying to remember that greater is an or. So if we look at an example, absolute value of 24 minus q is less than or equal to 11. So because this is less than, when we separate it, it's going to be an and. So we write it without the absolute values, just like it is. Then we write and we write it 24 minus q. The first part doesn't change. Now the inequality flips over and we make a negative 11. So when we rewrite it the second time, we flip over the inequality and we make the 11 negative. So we'll go ahead and solve this. So we're going to minus 24, minus 24. So we have negative q is less than or equal to negative 13, divided by negative 1, which means we need to flip over our inequality. Then over here, we're going to minus 24, minus 24. So negative q is greater than or equal to negative 35, divided by negative 1. So because we divided by a negative, we need to flip over our inequality. And then we have a positive 35, so we graph it. 13, 35, greater or equal to 13, greater than or equal to 35, and then because it's an and, it's in between. All right, and then we'll look at the grade or example. So we're going to have 2/5 x minus 8 plus 4 is greater than or equal to 12. So on this problem has this little extra guy right here. So step 1 is always to get the absolute value by itself. So we're going to minus 4 from both sides. So I'm going to have 2/5 x minus 8 is greater than 8. So we minus 4 from both sides to get the absolute value by itself. Now we're going to separate it. It still is a greater than sign, so that means or. So we're going to separate 2/5 x minus 8 is greater than or equal to 8, or 2/5 x minus 8 is less than or equal to negative 8. So again, we changed this guy's inequality, flipped him over, and we made this guy negative. But we only did that once the absolute value was by himself. We got rid of the 4 first. So now we solve this equation. I'm going to add 8 to both sides. I'm going to get 2/5 x is greater than 16 multiplied by the reciprocal. So we'll get x is greater than or equal to 40. And then we'll do the second part over here. So we're going to add 8 again to both sides. We're going to have 2/5 x is less than or equal to 0. And then again multiply by the reciprocal, which is just going to be 0 still. So this time, neither time did we flip over the inequality for the answer because we divided by or multiplied by a positive. So if we graph this, 0 is here, 40 would be to the right. Both of them get closed, and the 0 goes to the left, the 40 goes to the right. So again, that's going out for ORs.